We're going to look at some properties and how the intermolecular force, or the type of bonding, affects those properties. So first is melting and boiling point. We tend to say that ionic and metallic have high melting and boiling points, and then covalent is less than that. And that's because the intermolecular forces are weaker than the electrostatic forces found in ionic and metallic. Comparing those simple covalent molecules and looking at the intermolecular forces, hydrogen bonding is always higher, and London dispersion is the lowest melting point because of the strength of the attraction between the molecules. Now, when we talk about covalent, the macromolecules or giant covalent molecules are not included in that statement because they are bonded with covalent bonds, and it's not forces of attraction between molecules. So those macromolecules or giant covalent molecules have high melting points because the covalent bond has to be broken. Where in simple covalent molecules, we just have to overcome the intermolecular forces, and the bonds in simple covalent are not broken during phase changes. Solubility, remember, is the ability to dissolve in water. Nonpolar will dissolve other nonpolar solutes. Polar dissolves other polar solutes. So remember the term like dissolves like. There has to be something similar between the two, the solute and the solvent, in order for it to dissolve. Ionic dissolves in polar because you have that positive and negative that's similar to each other. And then giant molecular, those macromolecules, they do not dissolve because those bonds are so strong it would take too much energy to break them apart and dissolve them into a solvent. So giant molecular are not soluble. Everything else follows the rule of like dissolves like. And then finally we have electrical conductivity, or how well it conducts electricity. Remember, in metallic bonds, it's the moving electrons, or that sea of electrons, that allows it to conduct. Covalent doesn't conduct because we don't have positive and negative ions, so it just won't conduct. Polar sometimes can conduct, though, if they are ionized. So remember, ionized means they are broken into their ions, H plus and HCl, for example. So some polar molecules can conduct if we're able to ionize them. Acids are really the only ones that can be ionized because of the hydrogen being able to lose that electron. Graphite and graphene, which remember are allotropes of carbon, they can conduct because of those mobile electrons in the pi bond of the double bond. So those are allowed to conduct. Fullerene and silicon are semiconductors. They have mobile electrons, but they're just not really good about, they're not as mobile as those pi bonds are. And then diamond, which is in that tetrahedral shape, remember it has all of its electrons in sigma bonds, so they are not delocalized, therefore diamond does not conduct.